In this video, we're going to talk about how to compare groups of data using boxplots and histograms. So in the most basic case, we may have a data set like this, where we have, this is about book prices. And we have one column giving us textbook prices at UCLA, and then we have another column giving us textbook prices from Amazon. So we might want to compare the distribution of book prices between these two places where you can buy books. So what we're going to do is let's start with a histogram, okay? So we'll click histogram, and now because I want to compare both of these, I'll just simply select the two variables, and then I will hit compute. Now, just like in the previous video, when you do this, it'll just make a different distribution on a different page. And that is not so useful in comparing distributions side by side. For one thing, they're not side by side, and for another thing, the axes aren't really the same, so it doesn't make sense to compare the pictures like this. So let's go back to options. And one thing we can do down here is we can choose to use the same x-axis. That will help in the comparison, but what would be even better is if we put both the plots next to each other side by side. So if you want them side by side next to each other left and right, you want two columns, one column for each graph. So if I do that, I'm going to use the same x-axis, and I'm going to have them side by side, left and right. And so now we can see them side by side. So you might see some differences here. Looks like the Amazon data is a little bit shifted to the left here compared to the UCLA data. Another thing we can do here is we can do two rows and one column. And that'll put the graphs one on top of the other one. And so we can compare them this way. And this might be a better way to do it because we can line up the axes even better because the x values are right above one another, right, on the x-axis. So this might be an even better way to compare them side by side. So this is how we can compare histograms. Another thing we can do here is we could do box plots. So box plots are an excellent way to compare distributions side by side, especially if you have a whole bunch of distributions you want to look at, because box plots are very tidy and small. So let's do the same thing with box plots. We usually draw our boxes horizontally, so I'm going to go ahead and click that. And you'll notice it automatically puts them side by side on the same graph because box plots are just good for doing that. And so you can see the Amazon prices up here and the UCLA prices down here. And you can see the difference in the distributions side by side. Using the same axis, I don't have to specify that specially when we do box plots. Now, I wanted to show you another way in which this side-by-side comparison can come up, and a way in which it often comes up. So let's look at another data set. Here we have a data set for the salaries of teachers. There's a bunch of numbers here. Let's focus on the base salary for different teachers. We also have another column dedicated to the degree of the teacher, and you can see they either have master's or bachelor's degrees. So what we might want to do is compare the salaries of teachers who have a bachelor's degree to teachers who have a master's degree. Now, when I go and do this, notice that it doesn't make sense to choose degree as a variable for a histogram because it's not numerical. Histograms only deal with numerical data, so it doesn't even appear here as an option. What I really am studying here is the base salary. But how am I going to get two histograms, one for each type of degree? Well, I do that by choosing the group by option here. So if I group by degree, you can see now it's going to split the salaries into groups and make a histogram for each group based on what the value of the degree is, whether it's BA or MA. So if I compute, and let's do what we did before here. Let's go down and use the same x-axis and put 2 rows per page so that we have these histograms next to each other, all lined up. And so you can see these histograms next to each other. Now, one thing I might want to do, notice the width of the bars is different. If I wanted to make those widths uniform, I can do that. You can specify the width of a bar here. I might do bars of width 5,000, right? So now we have the same bar width. I've forced it to have a width of 5,000. That's one thing you might want to do. Now, like we did before, we can also do box plots. So let's take a look at that. All right. So the base salary grouped by degree. Let's draw our boxes horizontally, and it will automatically put them side by side. So here we have the box plots for the different salaries based on the education level of the instructor. So two different ways to make these graphs side by sides depending on what kind of data you have. Let's just go over the difference here. In the first case, we had data where the two things we were comparing were separate variables in the data set. They each have their own column, and we want a histogram or a box plot for one column and a histogram and a box plot for the other column. The other situation we looked at was where all the values that we were using come from a single column, but we want to group it based on the values of another column. So that is the distinction between the two methods that we just looked at. In the first data set we looked at, we had two separate variables we were comparing. And in that case, what we did is we just selected the two variables to make our plot. In the second case, we only had one column representing the variable that we wanted to measure. And what distinguished the two graphs that we were making were the values of another variable. And in that situation, that's the case where, oops, I don't want dot plot. That's the case where we want to group the data, where the values that specify the grouping lie in another variable. So two very different situations. I hope that helps you figure out what to do when you need to compare two variables. I hope that helps you when you need to decide what to do when you need to compare two variables side by side.